Let's do this problem from your lab assignment, section 6.2, problem number 4. Find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. Sketch the region, the solid, and a typical disk or washer. So we have the equation y is equal to 1/16 x squared. That looks like it's going to be a right side up parabola, vertex at 0, 0. X is equal to 6 is a vertical line that passes through 6, and y is equal to 0 is the x-axis. So we have a parabola, the x-axis, and x is equal to 6. So this thing uses x is equal to 0 as a boundary, but that's not one of our boundaries. And I think the same thing is happening for the second choice here. Except it goes to 4 only. This one x is equal to 4, this one x is equal to 6. So it looks like this is going to be the best candidate for our choices. We have the parabola, we have the x axis, that's y is equal to 0, and we have x is equal to 6. And this doesn't say anything about the right hand side, so it could possibly be, the left hand side could possibly be that we have a mirror image. But when we rotate it about the y-axis, when we rotated this about the y-axis, we'll see that other side come up anyways. So our region is not up against the axis of rotation. The y is the axis of rotation, and so whenever your region is not flush against the axis of rotation, there's going to be a hole in it. And so this space here is going to be a hole, and then the solid here, or the area here, is going to be spun around to make a solid. So this is going to be a washer, and this is our choice for the two-dimensional sketch. And then now if we take a look at this being spun around the y-axis, the outside is going to be a cylinder. It's going to be forming a cylinder. So when it forms a cylinder, it's going to look like one of these first two options here. It looks like this option or this option. And we have x is equal to 6 as our bound, so we have to go all the way to 6 out here. By the way, the y, if x is equal to 6, we have x squared is 36. 36 divided by 16. 16 is 30. 16 times 2 is 32, and so it's going to be a little bit past 2. And so this is exactly that point that we're looking at. And similarly, we have a washer that's going to be cut out. The outside is a cylinder because of this vertical line, x is equal to 6, that's going to be spun around, and in the inside will be a bowl. Okay, let's check that. So we are off to our next problem, or next part, step 2. We can rewrite 1/16 x squared as x is equal to, so if this is the washer that we're looking at, the radius, or since it's a washer there's a hole in it, so the radii, the two radii we're going to be looking for are values that are represented by x. So we need to write x is equal to something. X is equal to, it looks like the outer radius will be x is equal to 6, and the inner radius would be x is equal to that parabola. So we need to rewrite this parabola in terms of x. Now if we bring the 16 over to the other side, and then we take the square root, that'll leave us with 4 times the square root of x. So square root of 16 is 4, square root of x is just, square root of y. Square root of y is just square root of y. And technically when we're solving for this, there's a positive and negative, but we're just going to concern ourselves with the positive side because we seem to be looking at things on the right side. So let's submit that. And then the inner radius is going to be this exact function that we just found. So that's 4 times the square root of y. And then the outer radius, if you look at this washer, we make our cut down here, the radius is going to be 6. We move up here towards the top, the radius is going to be 6. Anywhere you cut it, the radius is going to be 6. So our outer radius is going to be 6. So the cross-sectional cut is going to be the outer radius squared minus the inner radius squared. So the outer radius is 6. So we'll say 6 squared. You could just put 36 if you want. Minus the inner radius, that's 4 square root of y squared. And so of course you can simplify this. This is 36 minus 16y. But fortunately our program does the equivalent, algebraically equivalent expressions. And so the volume of the solid is going to be between y is equal to 0 to y is equal to, okay, so 0, and then wherever 6 intersects that equation is what we want. So we want to know when 6 is equal to 1 over, oops, let's make this into a formula. We want to know where 6 is equal to 1 over 16 times x squared. Oops, x, this is y, is equal to 1 over 16 x squared. But we're looking at x is equal to 6. And so we're going to try to find the value of this. So again, it's 36 over 16. Let's see, let's take out a quick calculator. Might need maybe Wolfram Alpha to figure this out for us, or maybe you could just type in 36 divided by 16. That turns out to be, looks like 2.25, and so that's the decimal that they were looking for. Suppose you can write that as a fraction as well. So let's submit. And then now we figure out our volume. So our volume is going to go to 2.25, or 9/4 they have. And then the expression that's going to go in here is going to be the area, which is pi times, we calculated it already in an earlier step. That's 36 minus 16y. And then this is going to be making our cuts along the y. And then so now we just have to figure that out. So our antiderivative is going to be 36y minus 16y squared over 2. So let's cut that in half and then put the y squared. And then when we put 9/4 in there, we have, maybe we need to write this down. We'll keep the pi on the outside, so let's not worry about the pi. Let's put the pi here now, so we won't worry about it later. And now we have 36y minus 8y squared. When we put 0 in there, it's going to be 0, so that's not going to be a big deal. It's not going to change anything. But inside, we're going to put 9/4. And we're going to put 9/4 and square that as well. So let's see if we could do any simplifying. We have 4 goes into 36 9 times, so this is going to be 81. And then this is going to be 81 divided by 16. So let's put that down. 81 divided by 16. Oops. This is a times. And then the 16 would cancel out with this 8. This will leave us with a 1. And then this would cancel out. 8 would cancel. And it will leave us with twice that. And so we double this to get the common denominator. Well, it's just going to be 81 over 2. So let's type 81 pi divided by 2. And that should be the result. Okay, so this is another example of a washer cut along the y-axis. And that's it. I hope that helps.